Okay, so I got home and checked out the video from class, and unfortunately discovered that literally 5 seconds into the video, my voice cut out. I don't know if it was a battery issue. So what I'm trying to do is I'm going to uh, re-watch this video and try to point the highlights out. I don't remember what I said in class, but I am going to try to narrate through the issues that I was illustrating on the spreadsheet. So that's what I'm going to do now. So as you look down here in the right corner, you'll see my mouse move. That's how you can resize the screen so that you can make it either bigger or smaller by pressing that. All right, so let's say that there are, the University of North Carolina wants to talk about the salary of geography majors for their school. So they go through and they select the first student here who makes $25,000 a year. The second student makes $20,000 a year. The third student makes $35,000 a year. The fourth student makes $20,000 a year. And then the fifth student is a very famous person uh, who makes $3 million a year. Now, I could ask you if you know who this famous person is. I remember I did that in class. I asked around. I remember one person in one of my classes remembered, and that person is Michael Jordan. So, bet you didn't know that Michael Jordan was a geography major. I'm sure it helped him as he flew around all the NBA cities to do that. So anyway, one of the first things that we can do, what we're used to doing, is figuring out the mean salary. You commonly have called that the average salary, but I would like not to use what I refer to as the A word, average, and instead refer to this as the mean. So how do you calculate the mean? You simply add up all of the numbers in the column here and then divide by the number of people in this case, which is 5. Okay? So when I do that, it ends up that the mean salary at the University of North Carolina is $620,000 a year. Now, I would ask you all if you could change your major to geography and earn $620,000 a year, how many of you would do it? I certainly would. Certainly, that's a lot more money than I make as a teacher here at Utah Valley University. All right, so that's one measure of uh, the quote-unquote average. Now, I would like to ask if you all think that that is typical of what a geography major would make. So I think the answer clearly is no. Why is that not typical? Well, obviously, Michael Jordan is an outlier. And so we're going to talk about outliers more next week, how to calculate outliers. So I'm not going to go into that today, but just point out that clearly Michael Jordan is an outlier. And so the mean is highly influenced by outliers, such as Michael Jordan in this case. All right, so another method of measurement for the quote-unquote average is to figure out what the median is. And so the median is the middle value. The formula is given as n plus 1 divided by 2, where n is your sample size. So in this case, we've got 5 data points. Now, one of the things with the median that I need to do is I need to sort my data. And so I should sort it from low to high. But basically, as I do this, I'm just going to count my data. So if I've got 5 pieces of data, 5 plus 1 is 6. And here's how you can do that. So let me sort my data. You click on that sort by data, sort smallest to largest, and it sorts it just lickety-split like that. So now that I have 5 data data pieces here. So 5 plus 1 is 6. 6 divided by 2 is 3. So all I'm going to do is I'm going to count 1, 2, 3. That $25,000 salary is the middle salary. That becomes my median. So now what I would ask again is, do you between the mean and the median, which do you think is a better representation for the average, quote unquote, average salary? And I think you would all agree that the median is the best. So the third measure of quote unquote average is what we would refer to as the mode. The mode is the most common value, and as you can see, I've got two values there that are 20,000. So the mode, you could argue that that's the best representation for the quote unquote average salary, because 2 of the 5 students earned 20,000. So just a reminder on the mode, you can have no mode, you can have one mode, and you can have more than one mode. So in this case, we've got exactly one mode. 20,000 is the most common salary here. Now, let's say that I insert another student here. Another student makes 40,000. Now, that changed my mean, but of course now, instead of dividing by 5, I need to divide by 6, because now I've got 6 students here. So, I'm going to edit my formula. If I go up into the formula bar here, or I can also use the word average, because Bill Gates knows that, and so it will automatically figure out the count for me. So that changes the mean from 620,000 down to 523,000. So still, that would be a hefty salary. But once again, Michael Jordan is still an outlier, so we can't really trust the mean as a good representation for average. Now, I've got an even number for my median. Now, previously I had 25,000 listed. Now I've got 6 cells. 6 plus 1 is 7. 7 divided by 2 is 3.5. I can't really count to 3.5, so what I'm going to do is I'm going to count to 1, 2, 3, 4, okay, and I'm going to take the mean of those 2 middle values, okay. So this changes a little bit based on whether you have an odd or an even number, and so the mean of those 2 values would be 30,000, which means half of the students make less than 30,000, half of them make more than 30,000, okay. So you have to adjust a little bit depending on whether you have an odd or an even number of data points. Now the mode is going to remain unchanged. We still have 20,000 there. Let's say that I added another salary in here and I have $40,000. Okay, I put that in order. What is your mode now? In this case, excuse me, we have 2 modes. And so the other mode is 40,000. So this is in a case where we have 2 modes. Now, if I remove that 40,000 and that 20,000, what is the mode now? There is no mode. There is no most common salary. So at this point, you would say there's no mode. Okay, so just remember, you can have no mode, you can have one mode, you can have 2 modes. So those are your 3 quote unquote measures of average, and so you'll need to be able to do those on the computer as well as by hand. I know that on Monday when we do our quiz, I'm not going to allow you to use the computer. We'll do this mainly on on paper, so paper and calculator. So make sure you bring your calculators on Monday. Now, just as a reminder, the mean, if you are using the computer, you can use the command average, as I just demonstrated. If you want to know the median, the command for that is equals median, and then you just highlight your data, which I think I'm going to do here in a moment. But I believe I was having somebody ask me a question about the formula for the mean, which is equals average, and then in parentheses you just highlight your range. So here's the median command here. So equals median, and then you highlight your range again. So if you're on the computer, you can use that and it will figure it out. There is a command for mode, but it's actually very hard to use. I don't usually teach it because it's easier just to figure it out yourself. So especially if you have more than one mode, because if you use the command, it only returns one value, and sometimes there's more than one value, so it can be misleading. So I actually don't like to teach it, but if you want to get on YouTube or something and learn the mode command, you can do that as well. All right, so let's move on to the next section. This is 3.2. We're going to talk a little bit about standard deviation and measures of dispersion. So let's say that I had a couple of different farms and I wanted to buy some potatoes. So let's say that we have farm A and farm B. And hopefully, I've been actually keeping pretty good up here. I don't know what I was saying in class. Probably writing measures of dispersion on the board. And so we've got a farm A and a farm B. Okay, there we go. I'm catching up now. Farm A, farm B. So I want to buy a couple of potatoes at farm A. Farm A, I buy 2 potatoes. One potato weighs 4 ounces. The next one weighs 6 ounces. I go to farm B. I also buy 2 potatoes. One weighs 1 ounce. One weighs 9 ounces. So we can figure out the average, which is really the mean, because we don't like the word average. So the mean of farm A, I think you can figure that out in your head pretty quickly. 4 plus 6 is 10. 10 divided by 2 is 5. And 9 plus 1 is 10. 10 divided by 2 is also 5. So would it be consistent to say that the potatoes are exactly the same whether you buy them at farm A or farm B? I think most of you would agree that they're not the same. At farm A, they're much more consistent. One measure of dispersion we could measure is what's called the range. The range would simply be the maximum minus the minimum. And so at farm A, I don't know what I'm saying now, but it's basically going to be 2 ounces. Okay, I'm catching up here, the range. So the 2 ounce difference, basically you could write the range from 4 to 6. Typically I write that in parentheses, as hopefully I will do here in a moment. And then the range at farm B, okay, and now I'm catching up. So the range is going to be 2 ounces, or basically 4 to 6. So this is kind of how I would prefer that you write the range, to include the endpoints as well. You always write the lower number first. The range at farm B is 8 ounces from 1 to 9. So sometimes I will ask the class, where would you rather buy your potatoes? Most people say farm A because they're more consistent, it's got less variation. But occasionally I will get a student that says, oh, how about farm B? And I say, yeah, you're the gambler, right? You want to get the jackpot or not. Now, if we add a third potato, at farm A, I add one that's 5, and at farm B, I add one that's 5. So you can see the mean doesn't change at all. It's still exactly the same. And the range also doesn't change. So the range isn't very resistant to, when you add more data. So a better measure of dispersion would be what we would call the standard deviation. And the definition that I like to use is the average distance from the mean. Okay, so let's say that we go to a new farm and we get actually 5 potatoes, and these 5 potatoes are 1, 2, 3, 4, and 5 ounces. Okay, so I'm sure we can find the mean easily. I'm sure I picked on somebody to find the mean, and clearly without much thought that mean would be 3 ounces, which would also happen to be the median, but when we're doing the standard deviation, it's the mean that we are looking for. So the mean should be 3 ounces. Okay, so now I'm sure I picked on somebody in the class and I said, can you tell me the distance from the mean here? Okay, so the distance from 1 to 3 is 2 ounces. And then from 2 to 3 is 1 ounce, and from 3 to 3 is 0 ounces, from 4 to 3 is also 1 ounce, 5 to 3 is 2 ounces. Now, I didn't worry about negative signs. We should do that, but for illustration purposes, I just wanted to keep this simple. And so I picked on somebody in the room and I said, could you guess what do you think the average distance, the average of those 5 numbers would be? And I don't want you to do any calculations, but the person guessed 1.5. So that's actually a really good guess. And so that's kind of conceptually a good idea on what the standard deviation is. But of course, we're going to be doing a stats class. We've got to make this a little bit more complicated. And so I want to show you the actual formulas. So the formula, I'm going to speak it here, and then I'm pretty sure I will copy and paste it in a minute. But the formula depends on whether you're using a population or a sample. So remember last week we talked about the differences between population or sample. So the main difference is that you know, I'm going to pause for a minute. I want to make sure I get this in here so that as I read the formula, you'll be able to follow a little bit better. But I'll finish that one thought before I stop here. So if you're using the population, you need to use one formula, and if you're using the sample, so you have to decide whether the 1, 2, 3, 4, 5 represents a sample or a population. Most typically, when you're in statistics, we're going to be using samples, and so that's the S formula. And I'm going to cut out some dead air time here, and we'll jump ahead. So I'll pause for just a minute. Okay, so I apologize. I'm finding out here as this thing runs that I don't know, it cuts out all the time. So I just recorded 8 minutes and that got nothing. Okay, here's the formula. This is for the population standard deviation. It's sigma equals the square root of sigma times the sum of xi minus x bar quantity squared all over n. So this is actually the population standard deviation formula. Now, if you're using a sample, the formula is slightly different. It is this formula here, S equals the sum of xi minus x bar quantity squared all over n minus 1 and the square root of all that. When I paste it here, it's going to be gigantic. I got to resize it here. But as I do, so the question is, which formula do you use? And so the answer to that question is, it depends on whether you're using a sample or a population. So most of the time we're dealing with samples. You're going to use the S formula, the bottom formula. But there are times where you're using a population, and so you'll want to use the top formula. Now the formulas are very, very similar. As you can see, the only real difference is the denominator. 1 divides by n, 1 divides by n minus 1. So once again, that is due to the fact that you're going to divide 1 by, or one's for the population, one's for the sample. So as we go through here, we're going to do the data minus the mean. So in both cases, the numerators are the same. So I'm going to take the data, the first data point, which is 1, and I'm going to subtract off the mean, which is 3. Now, because I want this formula, I will always want to subtract F10. So I'm going to press the F4 key, and that will put dollar signs in there. And so that F10 will not change when I copy it. The F4 is a relative reference. The F10 with the dollar signs is now an absolute reference. So when I drag this down, it's going to give me the right formula. Now these two columns here, the one I just highlighted and this one, are basically exactly the same. The only difference is a couple of negative signs. Now I'm going to pay attention to those negative signs. Now the next thing my formula tells me to do is square the difference. And apparently I can't type here. I spelled it wrong 3 times, and I finally said, oh, who cares? But I'm going to take that cell -2. I'm going to raise that to the second power. That's the caret key. The shift 6, that's where you get that caret. I'm going to drag that down. Okay, so I'm doing that for every data. Now, in both cases, that weird looking E means sum. So that's the Greek letter sigma. Even Bill Gates knows that sigma means auto sum, and so that's why he put it on his button there. If we add up that entire column, that's going to give us 10. Now, the main difference between these two formulas here is, do I divide by n or do I divide by n minus 1? So the n is when I'm using the population, the n minus 1 is when I'm using the sample. I'm going to do it both ways just so you can kind of compare answers here. I didn't really specify what was going on, whether that was a sample or a population. But if I take that 10 and if I divide it by 5, I've got 5 data points there, so that gives me 2. If I take that 10, if I divide it by 4, using the bottom formula, that's 2.5. Okay, so this step here is called the variance. Now the first one is the population variance, and the second one is the sample variance. Now, later on in the semester, we're going to do a test called the analysis of variance. And so sometimes you're going to want to know the variance. Basically, that's everything except for the square root, the very last step. Sometimes you're going to want to know the standard deviation. Typically, at the beginning of the class, we're going to deal more with standard deviation. At the end of the class, we'll deal more with variance. So, just that's why we label that the variance. Now, the last step is to take the square root. So we're going to do the square root of both of those numbers just to compare. So the square equals SQRT of 2. That gives me 1.41. And then that's my population standard deviation. Then I'm also going to take the square root again for the sample. And so the square root of, in this case, 2.5 works out to be 1.58. Now you can compare those two numbers. That's the sample standard deviation there. You can compare those two numbers to our original guess of 1.5, and you can see that they're very close. In both cases, they're very close. So the idea was I just wanted to kind of give you a nice conceptual idea before I started throwing those two math equations at you. But the point is, on the test, I'm going to want you to do all of these steps. Now, I believe in class I asked, do you think that Excel can figure out the standard deviation without going through all these steps? And most of you said, oh, probably, and you're correct. And so I'm going to demonstrate here what the commands are, but I'm going to just emphasize that if you do this on the test and you don't show me the steps, you're going to get 0 points, okay? So the main thing that I want you to do is I want you to be able to go through all of these steps that I've just demonstrated. The test will be, we'll have a test Tuesday and Wednesday. Tuesday will be the written test. Wednesday will be the computer test. More than likely, I'm going to just put these steps here on the on the computer test. The written test, I'll probably just ask more concepts and that kind of a thing. So, so just keep that in mind. Monday, there will be a quiz, and I won't make you do this whole thing. But here's the commands for Excel. As you can see, there's a .p and a .s. As you can imagine, .p would be for the population standard deviation. .s would be for the sample standard deviation. I believe I said earlier the .s is the one that we're going to use most of the time. But if you are dealing with a population, you should use the .p. So I'll demonstrate how to do this here. The .p, if I just have to highlight my data, 1, 2, 3, 4, 5, and I get 1.41. So, and then the .s, I'll highlight that one, put my data in, and it gives me the same answer I got. So once again, you're welcome to check your answers, especially if you're doing your homework over the weekend, and you want to do these steps. You can check your answers and you can know immediately if you got it right or wrong. But I want you to do these steps here on the test on Wednesday. So that's what I expect to see on your Excel portion. So we will actually have several problems, so keep that in mind. I'm trying to remember what else I was talking about here at this point. So I can't remember anything else here. So just as kind of a little bit of a reminder on the test, this is test is Tuesday and Wednesday. Monday we will have class, and I will. Oh, I also forgot. So the end of 3.2, I did not finish talking about Chebyshev's theorem, and I did not talk about the 68, 95, 99 rule. I will talk about those on Monday. I'll probably go into 3.3 a little bit as well. So the stuff I talk about on Monday will be on the test on Tuesday. So just keep that in mind. And so the quiz on Monday will be on 3.1 and 3.2. So I think I'm running out of things to say now. So anyway, that's the lecture for 3.1, 3.2, which is mean, median, mode, standard deviation. is in 3.2, and that's all I have to say about that. So thanks for listening.